નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી.
Hello students, today we will study about some interesting patterns in the cubes and cube roots. This is the topic of standard 8 chapter number 7 cubes and cube roots. So in previous class we have studied about the basics, introductions of the cubes, right? Now let us study some of the interesting pattern. First is adding consecutive odd numbers. So, okay, first odd number is what? That is 1. And 1 we can write down as a 1 cube. Okay, now next two odd number after 1 is 3 and 5. So when we add 3 and 5, we get the total number is equals to 8. And 8 is the cube of 2. Right? Okay, now the third after 5 there is a 7 plus 9 plus 11. So when we add this three number, we get the total is equals to 27, and 27 is the cube. Which number? 3 cube. In the same way, after 11, 13 plus 15 plus 17 plus 19, that is equals to 64. 64 is a perfect cube, and it is a cube of 4. After 19, 21 plus 23 plus 25 plus 27 plus 29, the 5 numbers, that is total is equals to 125. It is a perfect square number and it is the cube of perfect cube number and it is the cube of 5. So here you can see if there is only one odd number, that will be the cube of 1. If we add the two odd numbers, we get the cube of the 2. If we add the three odd numbers, we get the cube of the 3. If we add 1, 2, 3 and 4 odd numbers, we get the cube of 4, and 1, 2, 3, 4, 5. 5 odd numbers means the cube of 5. Okay, so this is one kind of pattern that we are getting here while we add the consecutive odd numbers. But it is slightly different from whatever we are doing in the square, right? In the square we are adding the square numbers starting from the 1. Here we do not have to start from the 1. That we have to keep in mind. Okay, so if we need to find out the cube of the 10 cube, then how many odd numbers we have to add? 10 odd numbers. If we want to find out the cube of the 12, then how many odd numbers we have to add? 12 odd numbers. Because to find the 5 cube, we have to add the 5 odd numbers. To find out the cube of 4, we have to add the 4 odd numbers. So this is one kind of pattern that is we get by adding the consecutive odd numbers. Now let us understand the second pattern, that is cube and their prime factors. Now this word prime factor, you are familiar with this word prime factor, right? This is the term that you know now very well. If we have the number 4, we can prime factorize it as a 2 to the 4. Now when we apply the 4 cube, then 4 cube is what? 64. Now see, if we factorize the 64 in the prime factors, we get the 2 to the 4 to the 8 to the 16 to the 32 to the 64. So how many 2 we get here is 1, 2, 3, 4, 5, 6. 6 2 means we can make the pair of the 3 factors. Another pair of the 3 factors are here. So these 3 2 we can write down as a 2 cube, and later this 3 2 we can write down as a 2 cube. 2 cube into 2 cube. Now notice that the 4 has a 2 factor 2 and 2. So the 4 cube has the same factor 2 and 2 but with the cube. Why? Because 4 cube is there. That is why we have to write down the 2 cube into 2 cube. Understand? Let us see the 6. 6 is we can write down as 2 3s are 6. Now when we apply the cube of the 6, we get 216. And the prime factors of this 216 is this. Here we get the 2 3 times and 3 3 times. 2 3 times means 2 raised to cube and 3 3 times means 3 cube. Now here also you can see that in the 6 there are only two factors 2 and 3. But in 6 cube, the same factors are there, but with their cube. Okay? Okay. Now the same you can now think about the 15. 15 has a 2 factor 3 and 5. So in 15 cube, we get the 3 cube and 5 cube. This thing you can do for any kind of number, but you have to make the prime factors of the number that you want to factorize. Okay, so this pattern you can also notice in any other numbers. Okay, now based on this, let us study the exercise 7.1, question number 1. The question is, which of the following numbers are not perfect cube? So see, till now we have not studied any kind of method by which we can directly observe the number and we can say that it is a cube or not. But this is the method, adding consecutive odd numbers, and this is the method, cubes and their prime factors. So using this method, cubes and their prime factors, we can say that this is a perfect cube or not. But to do that, what we have to do? We have to first of all find out the prime factors of the number. And in the prime factorization, if we get the pattern of the three numbers, pattern that means the group of the same numbers, but they must be in the group of three numbers, so that we can say that it is a perfect cube. Otherwise, it is not a perfect cube number. So let us first of all factorize it. 218. So here first of all we can divide it with the 2. So when we divide it with the 2, we get the 2 ones are 2. Now we cannot divide it, so we have to take 0. Now 18 will be there. So 2 9s are 18 we get here. Now this number is not divisible by the 2 because 9 is there. Again this number is not divisible by the 3. Again it is not divisible by the 5. Now we have to divide this number with the 7. So when we divide with the 7, what we get? 7 ones are 7. So 3 is there and 39 we get. But 39 is also not in the table of the 7. So we cannot divide it with the 7. Okay. So now think about by which number we can divide this, or it is a which kind of number? Prime number or composite number? This can be the prime numbers because we cannot divide it with the 2, with the 3, with 5, with 7. Now let us divide it with the 11. So 11, in the 11 table it is also not there. In 13. 13 table, it is also not there in 13 table. Not in the 15, 17. No. 18, no. 19, no. Okay. So this is, actually we can say that this is a prime number. So we can write down this as, we can divide it with the 109, 109. So see, we can write down, these are the prime factors of 218. So we get 2 into 109. And these two numbers here are not making the pair of three same numbers. So we can say that the 218 is not a perfect cube number, right? This is not a perfect cube number. Okay, now let us take this number 46656. We have to make the same kind of the things. We have to factorize it. 46656. So when we first of all factorize, we can divide it with the 2. When we divide with the 2, we get the 2 2s are 4, 2 3s are 6, 2 3s are 6, 2 2s are 4, and 16, that is 8. Again we can divide it with the 2, 2 1s are 2, again 2 1s are 2, but 1 is the carry, 13 is there, so 2 6 are 12. Again 1 is the remainder, and 12 we get, that is 2 6 are 12, and 2 4s are 8. Okay, now divide it with the 2 again, because last digit we are getting the even numbers. Okay, so 2 5s are 10, 1 is the remainder, 16 is there, so 2 8s are 16, 2 3s are 6, 2 2s are 4. Again we can divide with the 2, 2 2s are 4, 18 is there, 2 9s are 18, 3 is there, 2 ones are 2, 1 is there, 12 is there. So 2 6 are 12. Again we can divide with the 2, 2 ones are 2, 2 fours are 8, 1 is there, 11, 2 eights are, 2 fours are 8. So 1 is the remainder, 11 is there, 2 fives are 10. Again 1 is the remainder, 16, 2 eights are 16. Okay, divide it with again with the 2, we get the 2 sevens are 14, 2 twos are 4, 18 is there, 18 is there. So 2 nines are 8. Okay, 729 is there. So now 729. We cannot divide this 729 with the 2. So we can divide it with the 3. Yes. So okay, when we divide with the 3, we get the 3 twos are 6. 12 is there. 2 fours are 12. And 9 is there. 3 threes are 9. Again divide with the 3. We get the 3 eights are 24 and 3 ones are 3. Again divide with the 3. We get the 3 twos are 6 and 3 sevens are 21. Again divide with the 3. We get the 9. When we divide with the 3, we get the 3. Again divide with the 3, we get 1. So see how many factors we are getting here. Here we are getting this. Now making the pair of the same factors. Here which this is the first pair of the 3 same factors. Again this is the pair of the same factors. Here also we are getting the pair of the same factors, and here also we make the pair of the 3 factors. So here no factors are remain as it is, right? All these numbers are in the group of the 3 numbers. So we can say that this number is a perfect cube number. This number is a perfect cube number. And what is the cube root of this number is 4, 6, 6, 5, 6. So it is not here actually to find out the cube root, but we can write down it as a cube root. Okay. So from this 3 we have to take 1, 2. From this 3 we have to take another 2. From this pair we have to take 1, 3, and from this we have to take one more 3. So when we multiply it, we get 2 2s are 4, 4 3s are 12, and 12 3s are 36. So this is a perfect cube number, and its cube root is 36. Actually we have not to find out the cube root, but it is just to understand. Okay, so now in this way we can understand that given number is a perfect cube or not. So here this number is what? Is a perfect cube number, and that perfect cube number and the cube root is 36. Okay, so this is all about this lecture. Thank you.
Thank you for joining us.